section 7.3 this time. Alright, so this is section 7.3, double angles, half angles, and product sum formula. So here's just a bunch more of these trig functions. So sine of 2x equals 2 sine of x cosine x. Cosine of 2x equals 2 cosine x squared minus sine x squared. But notice we can also change this one into cosine squared x minus 1 minus cosine squared x, and that's going to give us 2 cosine squared x minus 1. So sometimes we're going to want this one, sometimes we want this one, both are the same. Tangent of 2x equals 2 tangent of x, and 1 minus tangent squared x. So prove the double angle formula for cosine. So here, this is just to show where they came from. So here if we have 2x, it's the same as the cosine of x plus x. As we remember from last time, so this will be cosine of the first one, x, times cosine of the second one, which is x, minus sine of the first one, which is x, minus sine of the second one, which is also x. And so this is cosine squared x minus sine squared x. Okay. Alright, so if cosine x is negative 2 over 3 in quadrant 2, find cosine of 2x and sine of 2x. Okay, so how do we do this? So here, we go ahead and make our triangle. So this is in quadrant 2, so it opened this way. Notice we'll have minus 2 over 3, because this comes from what x is. Here we can solve for this, so this is 2 squared, so it would be 3 squared minus 2 squared. Oops, let me see if I can do that. 3 squared minus 2 squared, which is just 9 minus 4, so it's the square root of 5. Hold on. There we go. I forgot to mute anything in case somebody wanted to text me. So this is the square root of 5. And so here, cosine of 2x is equal to cosine of squared x minus 1, which is 2, times what we know at cosine of x was 2 minus 3 squared minus 1, which is equal to 2 to the 4 ninths minus 1, which is 8 ninths minus 1, which is minus 1 ninth. Okay, and then for the sine, so we have sine of 2x equal to 2. Alright, so sine of 2x equal to 2. So this is 2 sine of x, cosine of x, which is equal to 2 times the square root of 5 over 3 minus 2 over 3. And this is equal to minus 4 fifths. Square root 5, 9. Okay. So here we have this. Another way of finding out what sine of x is, we could have solved for it. That's why I paused. I was like, well, do I want to do that? I guess so. So we have sine squared x plus cosine squared x is equal to 1. That means sine of x is equal to the square root of 1 minus cosine squared x, which is square root of 1 minus 2 over 1 minus 2 over 3 squared, which equals 5 ninths squared, which is equal to the square root of 5 over 3. So that's just another way. You can do it without building the triangle. You can just solve for it directly. I don't always suggest that, but I mean, it's a useful tool to have in your bag, just so you know. Alright, so let's go to the next side. So let's write cosine of 3 in terms of this. So once you know the double angle formula, can you have triple and quadruple angle formula? Sure, right? And so here, we'll show you that we can do that. So here we just write cosine of 2x plus x is equal to cosine of 3. And so we have cosine of 2x cosine x minus sine of 2x sine of x. Here, I can plug in what I know cosine 2x is 2 cosine squared x minus 1 times cosine of x minus 2 sine of x cosine x sine of x. Simplify this all down. Here we get 2 cosine, go ahead and pull in the cosine, so cosine cubed x minus cosine of x minus 2 sine squared x cosine of x, and we want this all in terms of cosine, so we'll have to get rid of this. So here, we'll just go ahead and replace that with cosine cubed cosine of x. This becomes minus 2 sine of x is just 1 minus cosine of x, cosine of x. And then once I move this in and simplify everything, we're going to get 4 cosine. Oops, this is not squared, so here. So we pull this in. We'll get negative 2, so negative 2 becomes positive 2, so this ends up being 4 cosine cubed x. This becomes minus 2 minus 3, so this will be minus 3 cosine of x, and there we go. So now we've written this in terms only of cosine, so we can build these things if we so desire. Now what's the point of all this? Let's to verify more identities. So let's go ahead and do this. So let's just deal with this real quick. Let's just find out what sine of 3x is. Well, sine of 3x is sine of 2x plus x, which equals the sine of 2x cosine x plus cosine of 2x sine of x. And so then this is going to be 2 sine x cosine x cosine x plus 2 cosine squared x minus 1. So I'm just plugging in what I know 2 cosine is. Or sine of 2x is 2 sine x cosine x. Here, cosine of 2x is, make sure I'm writing on the right layer, 2 cosine squared x minus 1 times sine of x. Okay, so now that we have this, let's go ahead and just put it all together finally. So we'll start with the left-hand side. Alright, so I'll have 2 sine x cosine x cosine x plus 2 cosine squared x sine x minus sine of x all over cosine x. Oops, that's a sine, isn't it? Sine x cosine x. I guess it doesn't really matter. So notice here, I can pull out a sine everywhere. So one sine here, one sine here, and one sine here, and a sine here. So I can get rid of the one sine. And then I can get rid of a cosine. So a cosine here. Oh, but I can't get rid of the cosine everywhere. So let's go ahead and split that and then do that. So this would be 2 cosine squared x plus 2 cosine squared x minus sine. In fact, let's go ahead and put those two together. Just make this an even 4. And this will be, so go ahead and get rid of this, make this 4 minus sine of x divided by cosine x, divide this by cosine x. Notice here I can cross off one of the cosines, so I'm left with 4 cosine x oops, this is no longer sine, is it? I crossed that off, so this is just a 1 minus 1 over cosine x. But notice that's exactly what we want. It's 4 cosine x minus secant x, because 1 over cosine is secant, which is equal to the right hand side. So that's how we do that. So the only real trick here is to take the sine of 2x, convert it into what we know it to be in this cosine of 2x, and convert it into what we know it. And then it's just plug and play as before. All right. So this is how we can take double angles. So the next one on our little list is how to downgrade powers. So we can, so sometimes you just want to get rid of powers. And so here, if we have sine squared, I can solve using the cosine one. I can use that and solve to get here. Same thing for the cosine. I'll get the plus, and then the tangent, I can get this. And so here we're just manipulating these formulas, mainly these two, right, in order to get these, right? And then if I have tangent squared, same as sine squared over cosine squared, so it's this over this, and the twos cancel, so we'll get this. All right, so here's something. Express sine x squared and cosine x squared in terms of the first power of cosine. All right, so here, let's just plug in what these values are. So I'm going to zoom out so you can see them. So sine x squared is 1 minus cosine of 2x over 2. And then here I'll have 1 plus cosine of 2x over 2. That gives me, this is a difference of squares, so this will be 1 squared, so minus cosine squared of 2x all over 4. But notice here I have a squared, we don't want that, so we'll just go ahead and do what we're going to do. So this becomes 1/4, so this becomes 1/4 minus cosine squared, but I know what cosine squared is, so it would be 1 minus cosine of 2x, and so 2 times 2x would be 4x, all over 2, all over 4, which gives me the answer I think your book would like, is 1 plus cosine 1/8, I guess you can split that up, 1/8 plus cosine of 4x over 8. And here you can go ahead and do that and simplify just one step further, and this will give you 1/8 plus cosine of 4x over 8. And make it clear which I am doing and what. Okay, so now we have it all written as a single power of cosine. Now it's a quad angle, but some days you want this over other things. Alright, so let's go to the next one. So here are half angle formulas. What's wrong with zoom on in? I'll zoom on out. Alright, so sine of a half angle, here we can just use more manipulation. We can get that this is plus or minus the square root of 1 plus cosine x, plus or minus the square root of 1 plus cosine it, and tangent is either 1 minus cosine sine or sine plus 1 plus cosine. The choice of sine, so this is important, the choice of just signs depends on which quadrant x over 2 lies. Okay, so sometimes you want the positive, sometimes you want the negative. So here, half of this, so let's do this one together. So half of this, so I want to find this, so the exact value of that. Well, that's the same thing as sine of 45 degrees, right, over 2. And do I know what sine of 45 is? Yeah, so here it would be plus or minus, but I know which sign I want because both of these are in the first quadrant, so it would be strictly just plus in this case. The square root of 1 minus cosine of 45 degrees all over 2. So if I crunch that through, I'll get square root of 1 minus square root 2 over 2 over 2. Just to put it together, I'll make this 2 over 2 minus the square root of 2 over 2 all over 2. Here I can pull this 2 onto the bottom, and I'll get square root of 2 minus square root of 2 over 4, which is equal to 1/2 the square root of 2 minus the square root of 2. And I think that's about as clean as we can get it. All right. So find tangent of x over 2 if sine of of 2/5, x is in quadrant 2. So let's go ahead and do this. So here, if I have 2/5 in quadrant 2, I'll draw my triangle. I'll put my x here. There's a 2 here and a 5 here. And so we'll go ahead and figure out what's here. So it'd be the square root of 5 squared minus 2 squared. So that'd be 25 minus 4, which would be 21. But notice since I'm in quadrant 2, the x coordinate would be negative, so it would be negative 21. So here, the tangent of x over 2, but notice for tangent we don't need to worry about the sign, it's already built in, be 1 minus cosine of x all over sine of x, which is equal to, cosine would be 1 minus the square root of 21, so it'll be minus square root of 21 over 5, all over 2 over 5. I put this all together, so I'll have 5 over 5 plus square root 21, the negatives cancel, 5 over 2 over 5. Here I can safely get rid of all of my 5's, and then I'm left with 5 over 2 plus square root 21 over 2. And that's about as clean as we can get that one. Alright, let's do this next set here. Let's go ahead and zoom on in. Alright, so here's some more practice. So, oops, this should say sine of 2 cosine of minus inverse cosine of x. And I want this in x, where x is between here, because if x wasn't in here, I couldn't put it in for the inverse cosine. So, let's go ahead and figure out what x is. So here, we're going to assume, I'm just going to draw a triangle, so I'll have x, we'll have, oops. So let's assume the inverse cosine of x is equal to a theta. That's what we did all last time, so let's put in a theta here. Cosine is opposite, or adjacent over hypotenuse, and so this will just be the square root of 1 minus x squared. So if I had a 2 here, so it would be sine of 2 theta, which is equal to 2 cosine theta sine theta. Oops, I have that backwards. Does it matter? No. But just for consistency, let's keep it the same. Theta. So this is 2 times sine of theta is square root 1 minus square root x. Cosine theta is x. And so we can write this as 2x 1 minus square root x. Alright. Evaluate a sine of 2u if u is this and u is in quadrant 2. So let's go ahead and do that. Alright. So here, so u is in quadrant 2. And here I'll have my u here. Alright, so this will be minus 2 and 5. Here, once again, this will be the square root of 21. We've kind of already evaluated. 5 squared is 25 minus 4 squared is 4. Excuse me, square root of 21. Since we're in quadrant 2, this is positive for the y value, negative for the x value, or the x coordinate, right? Then, we'll go ahead and do this part where it says, so we're using the double angle formula here. So we sine of u equals, oops, I put that 2 in the wrong spot. So 2 sine of 2u is equal to 2 sine of u cosine u. So this is 2 times the square root of 21 over 5, and then minus 2 over 5. And so here we'll get 2, oops, minus 4 square root 21 over 5 times 5 give us 25. Okay, that's the square root of 4. Let me make this a little cleaner real quick. Let me just rewrite this just so it's a tad cleaner. This is 2 square root of 21 over 5, which would be the sine, right? 5 opposite over adjacent, times minus 2 over 5 gives us minus 4 square root 21 over 25. Okay. I guess I gave myself more room than I needed. It's better to have more room than not enough. All right. Let's look at these product sum formulas. All right, so here if I have, here's just a whole bunch of formulas. So here if I have u times v, so here I'm taking products, turning into sums. So here's all the possible product sines and cosines. Here are all my possible sums with sines and cosines, and I'm converting them to product. So this is sum to product and product to sum. So here I want to take this sums and convert it into a product. And so what do I have here? So here I have 7x plus 3x. And so we're going to figure this out. So here we're going to have, I have a sign and a plus, so I'm going to be using this formula here. So it'll be 2 sine of my u, which will be 7x, so 7x, plus v, which would be 3x, all over 2 times cosine of 7x minus 3x, u and v, all over 2. So this simplifies down to 2 sine of 5x cosine of 2x. Okay. All right. So here we have an identity that looks pretty ugly. Now, could we use our double angle form or triple angle formulas here and just kind of crunch through it? Yeah, sure. But it'd take a lot of time. But now we have more tools. And so the whole point of this next section, of this section, is to give you a whole bunch of tools you can use. So here we're going to be using this one, the minus, and then we'll be using the plus. Let's see what we get. So here I get 2. I'm going to zoom out so you can see it, even though my handwriting will get worse. So it'll be 2 cosine of u plus v, so it'll be 3x plus x all over 2 sine of 3x minus x all over 2 divided by 2. Here we have cosine, so cosine plus would be cosine of 3x plus x all over 2. This will be cosine again, cosine of 3x minus x over 2. I simplify all this down. We don't need those, so I can zoom on in. So this is 2 cosine of 4x over 2, so it'll just be 2x. Sine of 3x, or 2x over 2, so this would be x over 2 cosine of 2x over 2, so this is, or 4x over 2, so this is just again cosine of 2x, and then this would be cosine of 2x over 2, so it'll just be cosine of x. Here we have the 2's, these cancel, cosine 2x cancel, so I have sine over cosine, which is tangent of x, which is equal to my right hand side. So the only thing that you need to pay attention for all this right here, is that this is just a bunch of tools in order to solve all of these trig identities, and so this is just a big set of new material. Just a bunch of formulas. So my suggestion, if you're in the remote class or the online class, have a formula, write these all down at least once, and do that. And if you're in the normal class, write these all down, and have them somewhere. So either class, go ahead and just write all these down. Okay, well that's the end of this section, and we'll call this video complete.